So here's another problem that gave some people problems, and this has to do with double arithmetic, right? So floating point arithmetic. We're assuming that x is a double, and you could see here we're dividing by a double, and we're also multiplying by a double. So what our flag should go off that round off that round off error is going to be happening here. And so logic would tell you if we were dealing with integers, then the result of this would be 3, right? And then these two would be equal. But since we're dealing with doubles, it most likely will turn into 2.9999, and this will not be equal, right? So let's go ahead and look at our answer choices. We'll always evaluate to false. That's not true, right? I think if we do 1.0 here, there's a chance. It's like I think the round off error is like 9 out of 10 times there's a round off error. But then there's that 0.1% of the time where there is no round off error when you do arithmetic with a double. So number A is not possible. And then we have B may evaluate to false for some values of x. That is true, right? So some values of x, most values of x would result in a false evaluation here. And then we have C will only evaluate false when x is equal to 0. Well, when x is equal to 0, then we get arithmetic error, right? Because we're dividing by 0. So that's a runtime error. So C is not a choice. And then D, it will evaluate to false only when x is very large or very close to 0. So this one might set off an alarm like this is it, but it is not it because again, it's 9 out of 10 times there's a round off error. So then there are some very large numbers where this will not cause a round off error. There are some very small numbers where this will not cause a round off error, right? 1 out of 10 times it does not. So D is not an answer. And then E will always evaluate to true. That is not the case for reasons we've gone over. So the best answer is right here. It is B.